In this section, we're going to look at something called recursively defined sequences. So we're going to start with this warm-up. Find the next three terms in the sequence. Do you notice a rule or a pattern? So if you notice the pattern for this one, to find the next term, you're going to add the two previous terms. So for example, 1 plus 1 is 2. And then if we have 1 plus 2, we get the 3. 2 plus 3 is the 5, and so on. Draw my arrow here. So the rule or the pattern is you add the two previous terms to get the next term. So for example, we have 8 plus 13. If we add 8 plus 13 to get the next term, we get 21. Then we can add 21 plus 13, and when we do that, we get 34. And if we add 21 plus 34, we get 55, and so on. This sequence has a famous name. It's called the Fibonacci sequence, and we'll be taking a look at this a little bit later on in the unit. Let's look at some more sequences here. So we have a sequence in the first column of our table, and can you figure out the rule or the pattern and the missing term for each of these? So I'll give you some time to look through that, and then we'll go over the missing terms and the pattern. So for A right here, the missing term is negative 48, and the rule or the pattern is you multiply each term by negative 2, and that will give you the next term in the sequence. We take a look at the next one. It is 1. I'll keep this 1 right here. And to get the next term in the sequence, you're going to multiply by 2. All right, the next one, the missing term would be a negative 1. And to find each term, we add 1 to the previous term. Next one, the next term would be 50, the missing term. And this one we would multiply by half, or we could say divide by 2. Sequence E right here, switch colors. This term would be, let's see right here. This would be 42. And to find each term, it looks like we're adding, 1.5. And the last one, the missing term would be a 1, and we're adding 3. The following sequences are arithmetic on the left-hand side, and on the right-hand side, they're geometric. Can you figure out the rule for each one? And then can you classify the sequences above as arithmetic or geometric? So while you're looking at these, figure out what makes something arithmetic and what makes something geometric. So if we look at arithmetic, the first rule is we're going to add 2. Here we add negative 1. Here we add 0.5. For the geometric here, this one we're going to multiply by 2. The next one we're going to multiply by 1/3. And this last one here we're going to multiply, by negative 4. So what makes something arithmetic versus geometric? Well, if you notice, all the arithmetic we're adding, or we could say subtracting. And for the geometric, we're multiplying, or we could say we're dividing. So if we look above, all the ones in blue here, the ones that we multiply, these are all geometric. We're multiplying, or here we're dividing by 2. It's the same as multiplying by 1/2 in sequence D. And the rest of them we're adding or subtracting to find the next term. These are arithmetic. Whoops. Okay, so this is arithmetic. arithmetic, and I accidentally erased one that was geometric. All right, so there it is, a geometric sequence. To find one term, you multiply to get the next term, and arithmetic, you add or subtract to get the next term. So let's write that down. Again, geometric, I'll start there. You're going to multiply or divide, but we usually look at multiplying to find the next term. And what do we multiply by? It's called a common ratio. So whatever you multiply or divide by, that's called that common ratio. What's that number you're multiplying or dividing by to find the next term? If it's arithmetic, you're adding or subtracting to find the next term, but we usually look at adding. You can add a negative as well. So you add to find the next term. And what you add or subtract, that's called a common difference. And these words that I've been using, sequence and term, let's define those as well. So sequence is an ordered list of numbers. And the term is each number in the sequence is called a term. Okay, so each number in the sequence is a term, and a sequence is an ordered list of numbers. So we can write equations many different ways, and one way is called a recursive equation or a recursive formula. The definition of a recursive formula, how do you use the preceding term to find the next term in the sequence? So for example, if we look at the first arithmetic sequence, we have this first term. Now the notation for this, you'll see many different ways. U sub 1, you'll also see A sub 1, but both of these mean first term, and the first term in this sequence is negative 1. Okay, so there's our first term, negative 1. The common difference is what we're multiplying or adding or subtracting for arithmetic. What are we adding or subtracting by to find the next number? And if you notice, 3 to 7, 7 to 11, we're adding a 4. So there's our common difference. I'll put CD for common difference. And then the recursive formula, you need the starting value. So here are our starting values. So we can either say A sub 1 or U sub 1. The starting value is negative 1. And the recursive formula, to find any term, U sub n, sub means subscript, to find any term, we take the term before it. So the term before it, so n is any term, n minus 1 means the term before it. And then we are going to add 4. Okay, so again, this is a recursive formula. You need a starting value, where are we going to start at? And then to get any term, how do you use the term before it? So here's U sub n minus 1, the term before it. What are we going to do? We're going to add 4 to the term before it. Okay, so we're going to practice using this notation quite a bit in this chapter. Let's look at a geometric sequence. So here the first term is 1. So again, you'll see it A sub 1, U sub 1, first term is 1. The common ratio, what are you multiplying or dividing by to find the next term? So how do we get from 1 to negative 2? Negative 2 to 4. And if you're unsure, divide. What is negative 8 divided by 4? What's 4 divided by negative 2? And that is a negative 2. You're multiplying by negative 2 to find the next term in the sequence. So the formula, again, we need to define our first term. U sub 1, first term, is 1. To find any term, we take the term before it. U sub n minus 1 means the term before it. And we're going to multiply. So you can put a times or parentheses or a dot. I usually use parentheses. Multiply by negative 2. Sequences can have the same formula, but because they start at a different number, they have different patterns. They are different patterns. So if we take a look at 1, 3, 5, 7, and 2, 4, 6, 8, they have the same common difference, so you're adding 2 every time, but they are not the same sequence because they have different starting values. So the point is you need a starting number when you write this recursive definition. Okay, so we're going to practice that, and we're also going to look at something called the explicit notation, which you'll find as review. So let's do a few more examples of this. Example 1, a concert hall has 59 seats in row 1, 63 seats in row 2, 67, and so on. Write the recursive formula. All right, I'm going to make a table for this. So I'm going to say, all right, here's our row number, and here's the seats. All right, so in row 1, we have 59 seats. In row 2, we have 63. In row 3, we have 67, and so on. Write the recursive formula. So recursive formula, we need the starting value. So here the starting value is 59 seats in row 1. To find any row, you take the row before it, and here we are adding 4 every time, so plus 4. So there's a recursive formula. B, write an explicit formula. So think back to the functions unit. This is a particular function. So I'm talking about, is this linear? Is this a quadratic, exponential, square root? What type of function is this? And here, since we're adding 4 every time, if you were to graph this, plus 4 every time, this would be a slope of 4, which means this is linear. And if it's linear, we need y equals mx plus b, our starting value, and our slope. So if we take a look at this, our slope is x. What is our starting value? Well, the starting value would be if there was a row 0, how many seats would there be? So let's go backwards. If we do 59 minus 4, we will get 55. So if there was a row 0, it would have 55 seats. So there's 2 ways to write this formula here. We have recursion. The starting value is 59. We add 4 every time. Or we could write it as a linear equation. The y-intercept, the starting value is 55, and the slope is 4. All right, next question. What does U sub 4 mean? And it means this is row 4. How many seats in row 4? And there's a few ways to solve this. We could just look here in our table, add row 4 here, and add 4. So we have 67 plus 4 would be 71 seats. So we could say, all right, U sub 4 equals 71. Another way we could figure it out is putting it into our explicit formula here, 4x plus 55, and plug in the 4 for x. So in the 4th row, we have 4 times 4 plus 55, and we should get 71. So you can either use your table, you can count up, you could use your calculator and type it in, and that would give you how many seats are in row 4. All right, D, how many seats are in row 95? All right, I'm going to show you how to do it a few ways. So I'm going to pop my calculator up. It'll take a second, I think. And I'll also show you how you can use it with the linear equation. So here, 95 seats. Here is the explicit formula. So we could solve this. We could subtract 55 from each side. So we get 4x equals, and I'll write it over here, so that is 40. So here x is 10, which means in row 10, so in row 10 right here, there's 95 seats. Or in our calculator, let's see if it popped up. Okay, so I'm going to show you how you can type it in recursively. Let me just go to Scratchpad. Okay, so if I type this in, my starting value was 55. Well, in row 0, let me see. Row 0, there were 59 seats. So I can hit 59 and enter. And then if I hit plus 4, A and S is kind of like the row before it, right? So U sub n minus 1. And there's row 2, row 3, row 4. And so we could have used that to figure out how many seats in row 4. Also, we're looking for when does it equal 95 seats. So if I keep counting this, so this is row 4, 5, 6, 7, 8, 9, 10, we can see in row 10 you have 95 seats as well. So you can use your calculator and figure it out as well, or use an equation. All right, let's take a look at something that's a little bit different here. So let me erase some of my work. All right, let's take a look at this next sequence right here. Is this arithmetic or geometric? So you have to figure out, are you adding or subtracting or multiplying and dividing to find the next term? In this one, you are multiplying, and to figure out what you're multiplying by, you can take any term and you can divide by the one before. All right, so if we do that, 8 divided by 2 is 4, 2 divided by 4, oh, that doesn't work, so it's not geometric. So let's see if it's arithmetic. We have 8 minus 2 is 6, two minus a negative 4 equals 6, negative 4 minus a negative 10 equals 6. So here, this is arithmetic, and our common difference is 6. We're adding 6 every time. So to find the next term, you could go backwards, or dividing or subtracting to find the previous term, and then use that to figure it out. So here, recursive notation, starting value, negative 10. To find any term, you take the term before it, and we're going to add 6. So the explicit notation, again, our first term is negative 10, so we have to go backwards one more. Negative 10 minus 6 is negative 16. So y equals, we start at negative 16. our slope goes next to the x, which is 6. So there's the explicit notation. So 2 ways to write this. Find u sub 7. Again, you could type it in your calculator. So I'm going to hit Doc B and clear the scratch pad. I'm going to type in our starting number, -10, and hit Enter. All right, now I'm going to add 6 every time. So u sub n minus 1 is like the answer key. So there's the second term, third term, fourth term. We want the seventh. So 5th, 6th, 7th. So the 7th term is 26. So we can say the 7th term is 26. Or you could have done y equals -16 plus 6 times the 7th term. So if we do that, 6 times 7 plus -16 should give you the same thing, 26, and it does. Which term gives an answer of 38? So again, in our calculator, we can count. So this is 7, 8, 9. The 9th term, so we could say the 9th term gives us 38, or we could plug into our equation here. So 38 equals -16 plus 6x, and we could solve that algebraically. We could add 16 to each side. We get 6x equals 3, 4, 5, 64, divide by 6, and then we should get the answer. Oops, let's see if I put that in right. Oh, 54, I'm sorry, I added that wrong. 1, 2, 3, 4. 54, this was a 1, sorry, so this is 54, and x equals 9. So again, a few ways to figure it out in your calculator. You could figure out which gives you an answer of 38, or use the explicit equation. So in your assignment today, you'll be classifying sequences, arithmetic or geometric, and then writing up the sequences as well.